Alright, YouTube, welcome back. It's another Friday night. You know what that means. Time to do some math. So tonight we're going to be looking at our non-degenerate conic sections. I know we've been getting a lot of requests for that, so we're going to go ahead and look at one of these formulas here, and we're going to break it down. We've got all these things we got to answer for it. So let's start off with our basic formula. We can see right here we have negative x squared plus 4y squared minus 8x minus 8y minus 48 equals 0. So the first step is to figure out what kind of conic section we're dealing with. So if we break it down to x and y as being a and c, we know that the product of a and c is going to be less than 0 because they have opposite signs. Therefore, we're dealing with a hyperbola. So now that we have our fancy dancy hyperbola, we're going to have to go ahead and figure some stuff out for it. First thing you're always going to want to do when you have your general formula is break it down and solve the squares. So we're going to go ahead and complete the square here. First thing we'll do, we have rearrange our formula so that we can have the positive terms up front, negative terms in the back. And then we're going to factor out a 4, and we're going to factor out the negative 1. After we get that, we're going to go ahead and just try to complete the square. So we're going to take our linear term, half it, half of negative 2 is negative 1, square it, get positive 1. That term will be inputted. And then since we're adding the 1 with a 4 outside, we're going to go ahead and have to add a 4 to the opposite side of the equation sign. Same thing over here. We're going to take the 8x, half it, get 4, square it, get positive 16, input it. 16 with the negative 1 though becomes a negative 16, so we're going to make sure we subtract 16 from the right side. Going down, just simplifying everything out, we're going to have 4y minus 1 squared minus x plus 4 squared equals 36 once everything's reduced and simplified out. And then we're just going to divide both sides by 36 so that we can get into our general standard form of hyperbola, which simply is y minus k squared over b squared minus x minus h squared over a squared equals 1. That's what we have right here. Now, since we know that we're subtracting the x term, that tells us a few things. So moving on, we're going to skip down here, and we're going to know that that is a vertical hyperbola because we're starting with a positive y and subtracting the x term. So finding the center of it, we're going to get hk, which over here we're going to have k with the y, h with our x. So we have h and k. So our center is going to be negative 4, 1. We just said it was a vertical hyperbola. We're going to have a transverse axis now that's going to be the axis running straight through the center line of our hyperbola. Since it's a vertical hyperbola, we know that the transverse axis is going to be vertical also. Therefore, it'll be x equals, right through our center point, negative 4. And it'll cut straight vertical through everything. Next, we need our a and b, which, going back to our standard form, we know a squared and b squared is 9 and 36. Just taking the square roots of those, we're going to know that a is 6, b is 3. And that's going to be our rise and our run for when we're creating and those are for the fundamental rectangle. Now, I've already got this one already drawn out, but we can go ahead and we can start, and we can just see already the center right here, negative 4, negative 1. And then we have an A, which is our run of 6, and a B, which is our rise of 3. Next thing they wanted us to figure out were our vertices. Now, since we already know this is going to be a vertical opening hyperbola, our vertices are going to be still at the center point, and then we're just going to go up the b units, so up 3 and down 3. So from 1 up 3, and we get point -4, 4. Down 3, we get -4, -2. And those are going to be the vertices of our hyperbola. Next, we're going to find the focus, well, 2 focus points, which are the foci. So we'll do c, which equals square root of a squared b squared, just Pythag. And once we put in our a and b values again, well, from down here, we're going to go ahead and we'll get c equals 3 root 5. So then we're going to do the same thing. Since the foci are going to be inside of our hyperbola, we're going to start with our center point, and then we're going to go up and we're going to go down. And that'll give us inside our hyperbola our foci points. Then we know that there's going to be some asymptotes. So the quick way to do it is you can just draw right through the corners of your fundamental rectangle here in the center. I keep screwing up that name. I don't know why it's not sticking, but we know what it is. Now with the fundamental rectangle, something that, in case you're trying to remember how to do it real quick, you have your center point, you have your A, you have your B. So you can just go over A units, make your mark, and then you know you're also going to have to go negative A units. And then same with B, up and down. And then you can just draw the dots, connect everything out, and you have your fundamental rectangle. That really helps out now when you're doing your asymptotes, because it goes straight through the corners and the center point. And these are going to be your 2 asymptotes. Now, if you have a stickler that wants to know the formula of your asymptotes, it's actually really easy to figure out. You have slope, which is always going to be your rise over your run. Let me go ahead and make it easier right here. So rise over your run, your B over your A. So your B, 3 over your A, 6. Which, once it reduces, is going to be plus or minus 1/2. So, basic slope formula, y equals mx plus b. If we go ahead and plug these values in, since we know that the asymptotes have to go through our center point, we can go ahead and use our center point, our x and our y, and then we'll go ahead and do plus 1/2 and a minus 1/2, and we can find out what our b value is. Here it's 3, -1. So when we go ahead and do with our value back in, we know our formula for our slope is going to be y equals -4x minus 1 and y equals -4x plus 3. And that is going to be your slopes for your asymptotes. And then, if you want to figure out your y-intercepts, you can just go back to your original formula, and I'm just using the one from the standard form of the hyperbola, vertical form, and plugging 0 in for x, solve for y. And then here, we'll have, go ahead and multiply 36, 4 squared, 16, 4y1 minus 1 minus 16 equals 36. Going to move the 16 over. Divide by 4, get y minus 1 squared equals 13. Take the square root, move the 1 over, and get 1, y equals 1 plus or minus root 13. So then you have a y-intercept of 0, 1 plus root 13, and 0, 1 minus root 13. For the x-intercept, since this is a vertical hyperbola, and we already know where our center point is, and we know where these asymptotes are, we know that this will never cross the x-axis. So we have no x-intercepts. Now for domain and the range, we know that the domain is going to be all real numbers, but the range is going to be negative infinity all the way up to the vertex here, which is going to be at -2 for the southern one, for the lower of the two, and then it's going to be unioned back to this vertex, which is at +4 to infinity. So negative infinity and -2, including -2, union, including the 0.4 to positive infinity. And when we sketch it out, it'll look something like this. With our transverse axis, x equals 4, -4, correction, going right through our center point of -4, -1. We have our fundamental rectangle because of our a value and our b value of 3 and 6, rise and run. We have our vertices at 4 and 4, -4, 4, -4, -2. We have our focus down here for this one at -4, 1 minus 3 root 5. Our focus up here for this one at -4, 1 plus 3 root 5. We have our y-intercepts plotted. And that's really all there is to it. It's that simple. And this is vertical hyperbola. Thank you.